Let us discuss the different functions we might define for a linked list. These are the kind of functions we may have. Inserting a node at the beginning. Let's say you have a linked list, you have head, then you have some nodes, and you want to insert a new element. So basically you create a new node and you point head here and you connect like this. So you are inserting a node at the beginning. The next one, you are deleting the node at the beginning. You want to make head point here and you want to free this node. Maybe you want to insert at end. You will create a pointer and you will hop the pointer and you will reach the last node, and then you will malloc a new node and connect like this. Deleting at end. When you delete the last node, you cannot do this, that you create ptr equal to head and you in a while loop reach ptr here and then you delete it. That doesn't work because the previous node next has to be set to null. So you will need a prev pointer also. Once you can stop at this node, then you can easily free prev next this node and you can set the next to null. These four functions, insert at begin, delete at begin, insert at end, delete at end, are instrumental in implementing stack and queue using linked list. For stack, you are deleting and inserting at either of the ends, begin or end. For queue, you will be inserting at one end and deleting from the other. Then you may have more functions. You may have function like insert after a given value. Let's say you have a linked list and you may say insert after the value 20. You want to insert 40 after 20, so you create a node and you connect pointers like this. That's insert after a given value. Similarly, delete a given value. Maybe you want to search for 20 and delete it. So you situate ptr here, you keep hopping till you reach that node, or rather its previous node, and then you delete that node. This is not very frequent, but you can give a logical index to each node. You can say that this is index 0, index 1, 2. This is the logical thing. The linked list is not an array. Or you can give the indices starting at 1. You can have an insert after index also, that go to that node, go to the 5th node and insert after that. You can have a simply for loop for I equal to 0, I less than 5 if you want to jump 5 nodes, and you do ptr equal to ptr arrow next, and then you can add after that. You can have a utility function to check if it is empty. You can search for an element. That means you will pass to this function a integer value if it is a linked list of integer, and you will search. This function will return the pointer to the node which has that value. Printing the entire content of the list. Counting how many nodes it is. For many functions, you can do a recursive as well as iterative functions because linked lists are recursive. You can define that a linked list is empty or linked list is one node connected with a linked list. Okay. So basically you can imagine that your linked list can be simply a null empty list, or linked list can be a node and then another linked list. So that means you can do something on this node and you can call the same function on the further linked list. So it allows you to write recursive functions very easily. Although you need to write them with care, the stack grows quite much when you have recursive functions. If your linked list has thousands of nodes, then the stack grows unnecessarily big. Freeing all the list, that means deleting every node, calling free on every node. And there can be more functions like reverse a list. Maybe you want to do search replace. You can think of many other functions. I have listed few and we will discuss their implementation in subsequent videos.